Okay, so here we go. We're going to explain how to do this worksheet, this homework on graphing linear inequalities. Remember that graphing an inequality is the same as graphing an equation. You first want to make sure that it's in y equals mx plus b form, which it is. You could clearly see your m value and you could clearly see your b value. The b value is the y-intercept. Here's the y-axis. We know that it's going to cross the y-axis at the value of -4. So we all put a dot at -4. Then from that dot, you rise and run according to your slope. So you rise 1 and you run 2. So from this dot, you're going to rise 1 and run 2 and put a dot right there. And of course, you're going to continue to rise 1 and run 2 and put a dot right there. And you could even use that pattern backwards. Instead of rising 1, running 2, running 2 backwards, down 1, backwards, down 1, backwards, 2, down 1. That way you could extend it in the other direction. So that's exactly like graphing a regular line in y equals mx plus b form. But the only 2 extra steps you have to do is, one, decide if this line that you're about to draw, if it's going to be a solid line or a dotted line. If it has a solid line underneath, it will be a solid line, but it doesn't have a solid line underneath, so it's not going to be a solid line. That means you must make it dotted. So you put like a dashed line or a bunch of dots between those dots. And then the second extra thing you need to do, or the second difference that you need to do is shade where your answers are going to be at. They're either going to be on one side of the line or on the other side of the line, depending on which points work. Now, you could go ahead and test a point like 0, 0, right? If I were to test the point 0, 0, 0 for x, 0 for y, I could plug in a 0 here. It'll say 0 is less than, and of course you have 1/2 times, and if you were to plug in a 0 for x and a 0 for y, and then you have the -4 at the very end, probably do that in black, what will it say? It'll say 0 is less than 0 minus 4. It'll say 0 is less than -4. And we know that 0 is less than -4 is a false statement. That's not true. So that means that this point right here, 0, 0, it's not a solution. So if this point is not an answer, that means that none of these points on this area above the line are answers. That means that the answers are on the other side, okay? So that's the way you should understand on how to do it, but there's a quicker, easier shortcut. The easier shortcut is, once you have y by itself, you could think about the y-axis, and anything above on the y is greater, anything below on the y is less. So as you read this, when y is by itself, it says y is less than. That means that you're going to have your answers below the actual line. Okay, so you're going to shade in this bottom part, right below the line. Okay. Let's move on to the next one, number 2. So this one, same deal. You start with the b value. The b value is +1, so you put a dot at 1. That's the y-intercept. And from that point, you're going to rise and run according to your m, according to your slope. Now, this is a negative fraction, which means it's not going to have a positive rise. It's a negative rise. I mean, it's going to go down 2 units. So from this dot, you're not going up 2, you're going down 2, but you always go to the right, whatever that denominator is. So you're going to go down 2 to the right, 1, 2, 3, and you're going to put a dot right there. And you could use that pattern backwards. Instead of down 2 over 3, go over 3 backwards, up 2, over 3, 1, 2, 3 backwards, and up 2, and put a dot right there. And then you could decide, is this line going to be solid or dotted? Well, there is a solid line underneath it, so this will be a solid line going through those points. And then after that, you got to state where your answers are going to be at. They're either going to be above that blue solid line or below that blue solid line. And just looking at that inequality, it says y is greater than. So if you put your pencil on any one of these dots, or any one of these on any part of the line, like let's say I put it on this dot right here on the line, and if I go greater than on the y, well, if I'm at the y value of 1 and I want to go greater than, that must mean that I'm going up, which means I'm going to be shading above, right? So I'm going to shade all of this up here. And again, just to review, we graph equations and inequalities to represent the infinite amount of answers that exist to an equation. Any point I pick up here, like if I were to pick the point 3, 1, that point right here, 3, 1. Let me actually write that down just to verify it, just to show you, 3, 1. That means that your x is 3 and your y is 1. If you plug in a 3 for x and a 1 for y, it'll say, now you don't actually have to do this, I'm just demonstrating how any point up here will work and any point down here will not work. So when I multiply negative 2/3 times 3, multiplying a fraction by its denominator, that will eliminate, and I'll end up with negative 2 plus 1, which is negative 1. And it does say positive 1 is greater than or equal to negative 1. So if you think about that, positive 1 is greater than or equal to negative 1, that's a true statement. That means that this dot right here, it does work. That's a yes. That means that that is a solution. That means that all of my solutions are on this side. Now I already knew that because y is greater than is above. Anything above that blue solid line will work. It will be a solution. Anything you pick over here will not work. So if you were to pick any point down here, plug in that x value, plug in that y value, it will be a false statement. Okay, so I'm over-explaining all the reasonings and the thought behind all this. But the quick and simple way of doing this is graph it like you were graphing a regular line. It crosses at 4, put a dot there. And then from there I go down, because it's negative, down 5 over 2, down 1, 2, 3, 4, 5 over 1, 2, put a dot right there. And you could continue to go down 1, 2, 3, 4, 5. I'm off the graph. 1, 2, put a dot over here off the graph. But see, at the very least, I know it's off the graph, but at the very least, when you draw your line, and before I draw, is it a solid line or a dotted line? Solid, okay. So before drawing that solid line, or as you draw the solid line, that dot that's off the graph, at least you know to point your arrow towards it. You don't have to draw it all the way off the graph, but you're going to point your arrow towards that. Okay, and you put an arrow on both sides of this line. And then after that, you have to shade either above the line or below the line. So what does this say? It says y is what? Less than. So am I going to go above on the y or below on the y? Below. Less than is below. So if I put my pencil, let's say at this dot right here, that's the y value of 4, right? 1, 2, 3, 4. Where is below 4? Where is less than 4? It's below. So you're going to shade below. Right? So you're going to highlight everything that's below. All right. Let's move on to the next one. Number 4, let's begin. The b value is negative 3. So we put a dot at negative 3 on the y-axis. That's the y-intercept. And then the slope, the m value, is rise 7, run 2. Rise 7, this is stinking steep. So from this dot, you're going to go up 1, 2, 3, 4, 5, 6, 7, and you're going to run 2. You always run to the right, 1, 2, and you put a dot right there. And that's pretty much all that I could fit. I'm not going to rise 7 again. I'll be way off the graph. So before I draw my line connecting these two dots, I need to ask myself, is it solid or is it dotted? What do you say? Dotted? Absolutely. It doesn't have a solid line, so it's not going to be a solid line. So it's going to be dotted. So we put a bunch of dots all the way through, put some arrows on it, and then you shade either above or below, but it's so steep that you might be thinking, do I shade the left side or the right side? It's not really left and right. We're going to be thinking of up and down because y is by itself. So go ahead and put your pencil on any dot on this line. I'm going to put it on this red dot at the y value of negative 3, and I want to represent the y values that are greater than negative 3. So where's greater than negative 3? It's above. So I'm going to be shading everything that's above the line, okay? So you're going to shade above that negative 3 value. So that means you're going to shade in everything over here. I know, fun stuff. Does it get more fun? Heck yeah. Check out number 5. This one's so easy that you might get confused, right? You have y is greater than negative x. So step 1, based off of yesterday's notes, is to rewrite it in slope-intercept form, y equals mx plus b. Is y by itself? Yes. So it technically is in y equals mx plus b form, in slope-intercept form. What is your slope? Your slope is always the value in front of x. So in this case, it's a -1. However, you want slope to be in the form of rise over run, in the form of a fraction. So go ahead and put it over 1. That way you know that your m value is -1 over 1. What is the b value? There is no number that you're adding or subtracting at the very end, what number represents nothing? A 0. So you could go ahead and put a 0 right there, and that will be your b value. Okay? So this is in slope-intercept form. It crosses the y-axis. Our y-intercept is at 0. So go to the y, go to 0, put a dot right there. That's technically at the origin. And then from that dot, we are going to rise and run, but this is a -1 for the rise, so I'm just going down 1 over 1, and you put a dot right there, and then down 1 over 1, put a dot right there. So your dots are going to be going down 1 over 1, down 1 over 1, all the way through, and you could use that pattern backwards, extending it in the other direction all the way through. And then you got to ask yourself, is this going to be a solid line or dotted? Obviously, no solid line. It's not going to be a solid line. It's going to be a dotted line. So we put some dots between the dots. And then we have to ask ourselves, are the answers above or below? What do you say? Are they above or below? Above. Because y is greater than. If you put your pencil on any dot on this line, doesn't matter which dot it is, you could put it here. This is at the y level of 2. And greater than 2 is going to be up here at 3, 4, 5. So you're going to be shading above, shading above, shading above. So we're going to shade everything that's above the line. Everything that's above this line, we're going to shade it. Just need to fill in this highlighted triangle. And then we're moving on to the next one. Now, if we look at 6 and 7, those are interesting ones because it has a single letter and a number, okay? So I hope we remember what we went over yesterday, that if you have y and a number, y equals a number will be a horizontal line crossing the y-axis at that value, okay? So y equals 2 is going to be, if it were y equals 2, it'd be a dot at 2 on the y, and it'd be a horizontal line crossing right through it. Y equals -3 would be a dot at -3 crossing the y-axis at -3. Y equals +4 would be crossing the y-axis at 4, and it'd be a horizontal line crossing the y-axis at +4. But right here you have y is less than 2. Okay, so we're going to go to 2, and we're going to draw a horizontal line. But before I draw my horizontal line going right through 2 on the y-axis, I need to decide if it's solid or dotted. And obviously this is what? Dotted, because it does not have a solid line underneath it. So we do a dotted line going right through it. And then in addition to that, we need to shade either one side of the line or the other side of the line. This says y is less than 2. So if you put your pencil on any part of this line, you're at the y value of 2. Which way is less than? Is it above or below on the y? Below, right? So right here I'm at the y value of 2. Less than 2 is 1, 0, -1, so it's below. So we are going to shade in everything that's below that line. So I just need to fill all of this part in. And it's not like it just stops right here. It actually is forever. There's an infinite amount of answers. So let me fill this in. And there we go. Now compare that to number 7. X is greater than or equal to 2. Okay, so right here, when you have x equals 2, you go to the x-axis, you go to 2, you draw a vertical line. You had x equals -2, you go to -2 on the x, draw a vertical line. If you had x equals +4, you'd go to +4 on the x, you draw a vertical line. So y and a number is a horizontal line crossing the y-axis at that value. X and a number is a vertical line crossing the x-axis at that value, okay? So right here, x is greater than or equal to 2. You go to 2 on the x, you put a dot right there, and you draw a vertical line right through that x value of 2. The question is this going to be a solid line or a dotted line? Solid line, because it does have a solid line underneath the inequality, right? There's a solid line underneath it. That's why this is a solid line. Now, I still need a shade, and a lot of people freak out right here because we can't use the logic of above or below, because when you have y by itself, that's when you could say, okay, y below, y is less than, that means below, because y is up and down. If it were y is greater than, it'd be above. So right here, there is no y. So you can't think of above or below anymore. you got to forcefully think of the x. And x is no longer up and down. X is the left and right. And we should all know that x greater than is to the left or to the right? To the right, right? X is greater than is to the right. So you got to fill in the right side of this solid blue line. So let me highlight everything on this side of that solid blue line. Ta-da! And number 8, y is less than or equal to x. Is that in slope-intercept form? Is y by itself? Yes. What is my m value and y equals mx plus b form? Yeah, my m value is what number's in front of x? There's an invisible 1, huh? So you want it to look like rise over run, make it a fraction, put 1 over 1. That's your m. You're going to rise 1, run 1 from the b value, from your y-intercept value. What's the b value? What's the b value? There is no b value, so it's 0. So it crosses at 0, put a dot at 0, and from that dot, you're going to rise and run according to your slope. Rise 1, run 1, put a dot right here. Rise 1, run 1, put a dot right here. And you're going to continue with that pattern till you go all the way through, and you could use the pattern backwards to extend it in the other direction. And we do know that this will be a solid line because it has a solid line underneath the inequality. So I will draw a solid line, not a dotted, going right through these red dots. And now I either shade one side of the line or the other. Because y is by itself, I could think, do I shade above or below? What does this say? Do I shade above or below? Below, because it's a less than symbol. So if you're at the y value of 0, 1, 2, 3 would be greater than. -1, -2, -3, that'd be less than. So y is less than, that means we're going to shade below. We're going to shade everything below this blue line right here. Fun stuff. Okay, so this video that I'm recording right now, as I speak, as I teach, is already 17 minutes long. And it's a good place to stop right here because all of these have been simplified inequalities. Every single one of these have been in slope-intercept form. They're already ready to graph y equals mx plus b. All you got to do is look at the b value, then rise and run according to your slope, then decide if it's solid or dotted, and then decide what part to shade, either above or below. I mean, unless you have the x on a number, it's a little different, but it's all the same concept. It's all simplified. Starting on number 9, we no longer have simplified equations. We have to do some type of math to do step 1 to rewrite it in slope-intercept form. And that's where I'm going to pick up on the next video.